we've looked at this before, but we want to do a quick review. Okay, now we have some changing velocities, so that means we're going to have some curved position time graphs, and we want to make sure that this all clicks. Okay, so we're going to take this velocity time graph and try to make an acceleration time graph, or a position time graph from it. Okay, now this one's going to be a little bit tricky, but we'll be able to work our way through it, I think. Now, remember, when I'm going from velocity to position, since velocity tells me how fast I'm going and which direction I'm moving, but not where I'm starting, I have to tell you the starting point. So we're going to say start at 0 meters. Okay, so this is my position graph in meters, time down here in seconds, and we're going to start from 0.
Okay, but if you scale it like that, I see at the beginning you're moving -1, which would be toward the detector.
Oh, so if I do that, then I wouldn't be able to really, well, that's a good call. Maybe we should go, well, how far are we going to move backwards here?
Looks like we need to take the area, correct?
Right.
The area of that rectangle looks like 2 meters.
Okay. 1, 2. And this one,
And
that
looks
triangle's
like a half.
So let's, instead of starting at 0, let's start at 3 meters.
Okay, that'll work.
All right, so we're going to start up here. All right, so, well, let's just go ahead and do this then. If we started at 3 meters, this velocity says...
Now that velocity says we're moving at a constant -1 meter per second.
Okay, which means
It's
that's
a straight sloping line.
Straight sloping line.
Every second you go backwards, I guess, 1 meter.
Towards the origin, 1 meter. Now, to double check ourselves, what's the slope of this line?
That line, definitely -1.
-1.
Rise over the run.
Which matches the value of this line. Okay, the area here is 2, so our displacement should be, or -2, our displacement is -2.
Now I see in the next second that your velocity is decreasing. You're going from velocity of -1 to 0 over the next second.
Okay.
So you're slowing down.
We're slowing down, but we're still moving towards the origin.
So we still need to come closer, and that's just an area of a half there.
A half, right? But our line's not going to just stay steep. It's going to get flatter, so it's going to be curved a little bit. Okay. Now the same thing's going on here, but what happened right there?
Okay, right there we traveled at 0 meters per second.
So that's a flat spot right there on my position graph.
Yeah, now it looks like you switch directions because remember, away is above the time axis here.
Okay.
So now we're moving away, but we're also speeding up because our velocity is increasing.
So how far did we go?
Let's see. Take the area. I think that is an area of 2.
There's an area of 2. So we got to go.
So we need to go up to
2 meters.
2.5.
In 2 seconds, right? I'm not going up to 2 meters. I'm going 2 meters from where I am, and that's going to happen in 2 seconds. And the whole time this happens, I need to be getting faster.
So I'm kind of have a curved line again.
It's going to curve up, okay? And then right away here, what happens?
Okay, now I'm looking at velocity. My velocity is starting to decrease. However, I'm still moving away from the origin because
it's
I'm still
positive,
above, yeah.
Right. Okay, now this is an interesting area right here because it's not just a triangle or just a rectangle.
Yeah, you got one of each there.
I got one of each. So this rectangle,
that's 2.
That's 2. And this triangle,
let's see, half base times height, 1?
1. So we've got to get 3 more meters.
Okay.
So from 2.5 up to 5.5 in 2 seconds. And the whole time that's happening, we need to be getting slower. So instead of just straight connecting the dots, I need to make that curve and get it flatter. Okay. All right. So that's velocity to position when we have accelerated motion. So it wasn't traveling at a constant speed the whole time. Okay.
And that wasn't too bad. Just take one section at a time.
Just one section at a time. And you're using areas here, right? We used areas here to get our displacements over here. And you can always double check yourself and go back and check your slope. This slope, if we look at this one, it's a negative constant. And we have a negative constant velocity. This slope starts steep and gets less steep. So this was negative and became to 0. Okay, so you can check yourself.